Objective 12.7, Statistical Measures. In this objective, we want to be able to analyze a data set based on measures of central tendency and based on measures of dispersion. So what exactly are statistics? Very simply, statistics are numerical values used to summarize and compare sets of data. So any kind of number value that we can use that will help us to summarize data or compare different sets of data could be considered a statistic. There are generally two types of statistics. The first type is called measures of central tendency. This would be a number used to represent the center or the middle of a set of data values. There are three different measures that we can use for central tendency, and each one has its own advantages and disadvantages, depending on the situation, depending on the context of the data that you're using, depending on what it is you're trying to find about your data. So the first measure of central tendency is called the mean, or sometimes we call this the average. This one actually has a symbol to it. It's the X with a bar across it. And the way we find the mean or average is to add up all of our data values and then divide by the number of data values that we have. This is probably the one we are most familiar with in working with different situations in the past. But there are two more that can also be very useful when we're looking for measures of central tendency. The second one is called the median. And the median is found by looking for the middle number when the data values are written in order. And that is the key to this. You have to make sure that you have a list of data values in order before you decide what your middle number is. If you happen to have a set of values where you have an even number of data values, then your median is going to be the mean of the two middle values. So you can only find a distinct middle number when you have an odd number of data values. If you have an even number, you have to take the two in the middle and find the average of those two. We'll see that in just a minute. The third measure of central tendency is called the mode. And the mode is the data value or values that occur most often. Now this is kind of a strange measurement because it's possible to just have one answer like you would expect with mean and median. It's possible to not have any mode. So if everything happens the same number of times, then you would have no mode. Or it's possible to have more than one mode. It's possible that two different data values might both occur the same number of times and be the most number of times that anything occurs. So this is kind of a strange measurement, but it can still be very helpful in seeing what comes up the most often. So those are measures of central tendency. We also have something called measures of dispersion. And a measure of dispersion is a statistic that tells you how dispersed or how spread out your data is. So one type is very simple. It's the range. To find the range, you simply take the difference of the greatest value minus the smallest value. And so that gives you an idea of how much your data values are spread out just by looking at what the difference from the biggest to the smallest is. The second type of measure of dispersion is a little more complicated, but it's incredibly useful when you really get into a high-level statistic class, and that's called the standard deviation. It also has a little symbol. It's a Greek letter, so it's a circle with the little tail on the top. Sorry, I don't remember what this one's called at the moment. I think it's the lower cases sigma, if I remember correctly. But just know that when you see this little 0 with a little tail on top, that we're talking about the standard deviation. And standard deviation describes the typical difference or deviation between a data value and the mean. So it's a number that kind of tells you how far from the mean your numbers are. The way to find it is a bit complicated, but you'll see that it's very doable, especially with a calculator, when we get into some examples here in just a minute. But for now, just know that this is the general form of it. Each time here, you're going to take the data value from your data set and subtract the mean for your data set. Okay, so every time that's what you're doing. The X subscript represents a data value. The X bar represents your mean. So you're taking the difference from your mean to your data point, and then you're squaring that difference, and then you're adding them all up. You're dividing by how many data values you have, and then you take the square root of the whole thing. Okay, we'll see how this works in just a second. So let's actually look at an example and start putting some of these measures to work. So it says the data sets at the right give the waiting times in minutes of several people at 2 veterinarian offices. So we have Office A, where people waited for these different amounts of time, and Office B, a different office where people have waited for these different amounts of time. So the first thing we're asked to find is the mean for each office. So remember, for the mean, we're going to add up all of the different waiting times for Office A. And then since we have 9 different waiting times listed here, we take this sum and divide it by 9. So the 14 plus 17 plus 18 plus 19 and so on up to 32 gives us 198. And then since there are 9 different values here, we take 198 divided by 9 and we get 22. So according to this, the mean waiting time in Office A is 22 minutes. Now we do the same thing for Office B. We add up all of their waiting times to get 144. And they also have 9 different values here listed. So we'll take the 144 divided by 9 and get 16. So the mean office waiting time for Office B is 16 minutes. Okay, so that's one number that gives us an idea of kind of what the central number is, or maybe you could call it the typical number is. And you should always notice that these answers should be somewhere in the middle of your data set. So 22, notice, is not actually one of the numbers we have, but it would certainly fit right here in the middle or in the midst of all the waiting times. 16 actually is one of the numbers, but it doesn't have to be. And again, it's right here kind of in the middle of everything. Now let's take a look at median. Remember, to find the median, we need numbers that are in order. Luckily, that is already the case in both of these situations. The times for both offices are already in order from smallest to biggest. So now we just need to find the one in the middle, which literally means counting from the outsides until you get to the middle. So in this case, you can almost think of it as there's the first one at the end. Here's our second one on each end. Here's the third one on each end. Here's the fourth one on each end. And so what we're left with here is the 20 as the number that is physically in the middle of all of these data values. So the median for Office A is 20 minutes. Now if we do the same thing for Office B, cancel out the first one on each end, second data value on each end, third one, fourth one, and we end up with a middle value of 18. So the median time for office B is 18. For our third, excuse me, for our third measure, we're going to take a look at the mode. Remember, this is the one that happens the most often in the data set. So when you look at all of the times in office A, the 24 happens twice, whereas all of the other data values only happen once. So that makes 24 the mode for office A. It's the one that happens the most often. In office B, the time that happens the most is the 18. It happens 3 times, whereas everything else again only happens once. So the mode for office B is the 18 minutes. Okay, so that gives us our measures of central tendency. Now let's look at dispersion. If we want to find the range for each office, we simply need to take the largest number minus the smallest number, which if you already have your numbers in order for the median, that's an easy thing to do because it's literally at the ends of your data. So for office A, I'll take the 32 minus the 14 and get a range of 18 minutes. For office B, I'll take the 23 minus the 8 and get a range of 15 minutes. So at least for these people that we're looking at and the times they had to wait, office A had a range of 18 minutes and office B had a range of 15 minutes. And then for standard deviation. Now for office A, we already found a few steps ago that the mean for office A was 22. So we're going to need to use that now to set up standard deviation. Now I know this looks really complicated, but just take a look for a moment at what you're really seeing. What's happening here is that each of the data values from office A is being subtracted with the mean. So every one of these has a second number that is 22 because that was the mean that we found in step A. And then the other number are the data values from our data set. The 14 is here, the 17 is there, the 18, 19, 20, 24, 24 again because it happens twice, 30, and 32. And then each time that difference gets squared. So it's really not going to make a difference which way you subtract these, because whether you end up with positive or negative, once you square it, you get the same answer. So in this next step here, you're seeing the sum of all of those squares. So 14 minus 22 is negative 8. Negative 8 squared is 64. The 17 minus 22 is negative 5. Negative 5 squared is 25. 18 minus 22 is 4. 4 squared gives me 16. 19 minus 22 is 3. 3 squared gives me 9. 20 minus 22 is negative 2. Square that, I get a 4. 24 minus 22 is a positive 2. Square that also gives me a 4. And since 24 happened twice, I'll have those 4's twice. Then we've got a 30 minus 22, which is 8. The 8 squared gives me 64 again. And finally, the 32 minus 22 is a difference of 10, and 10 squared gives me the 100. Okay, so now in my next step, I'm going to add all of those up to get 290, and then divide that by 9, because again, we still have 9 different waiting times listed in our data set. So 290 divided by 9 gives me 32.2 repeating, and then when I finally take the square root of that, I get approximately 5.67. So that is the standard deviation for office A. Notice I don't have minutes or anything labeled on here because it's not really a minutes kind of answer. It's just giving me an idea of how much things are spread out. Now if I do the same thing for Office B, we found in Part A that the mean for Office B was 16. So now you'll notice the second number each time in my parentheses here is a 16. And then each of the first numbers are the numbers from the waiting times of Office B. So again, I take each difference and square it to get 64, 25, 16, 0, because I actually have a 16 minus 16 there, 4, 4, 4, 16, and 49. Add all those together, I get 182. Divide 182 by 9, I get 20.222, repeating. And then the square root of that gives me about a 4.50. So the standard deviation for Office B is 4.50. What this now tells me is that the spread of the times in Office A is bigger than the spread of the times in Office B. So the distance of the times, how far they are away from our mean in each case, is a little bit more spread out in Office A than it is in Office B. The bigger the number, the more spread out your data is. Smaller numbers represent tighter values, values that are more closely configured around the mean. They're much closer to the mean and therefore not as spread out. Okay, now let's analyze this a little bit. So let's say you were the marketing director at Office A. Which of your three measures, or which of any of your measures, would you use to advertise the typical waiting time? So you've been asked to put together an advertisement for this veterinary office, and they want to be able to state a typical waiting time. Which measure would you use? Well, the reason I started off with which of the three measurements is that you're probably going to choose one of the measures of center. That's the one that's going to give you sort of a typical idea of how long you're going to wait. But which one would you think is the best choice? The mean, the median, or the mode? Well, certainly if you're trying to advertise the waiting time in your veterinary office, you would probably want to go with the lowest time. So in Office A, the lowest time is the 20, the median. Okay, now if you're doing the same thing in Office B, the lowest time in Office B is the 16, which is the mean. But then you have to ask yourself, are these really the most typical times for each office? Now there really isn't any particular right or wrong answer to this. It's all about analysis. So when you look at this 20 compared to the data values, 20 really is right in the middle. It's the mean. It's the median. It really is physically right in the middle of all of your data. So 20 might be a good choice for Office A. In Office B, though, when you look at 16 compared to all of your other data times, you'll notice that there are only 3 times that are shorter than 16 minutes, whereas you have 5 times that are longer than 16 minutes. So even though 16 is your lowest measure, it might not really be the most typical time that you would have to wait. So you have to take all of those kinds of things into consideration when you're using these numbers or when you're being given these kinds of numbers to try to convince you of something. You need to be thinking about, well, is this really the most typical number? Is this really the best description of what's happening in my situation? Now, I've also asked you here, which office seems to have the more consistent wait times? Consistency would have to do more with the dispersion. you would want to look for an office with a lower dispersion to say that your wait times are more consistent. So both in terms of comparing the range and comparing the standard deviation, we would probably say office B is a little more consistent. They only have a range of 15 minutes compared to the 18 minutes at office A, and their standard deviation was smaller at a 4.50. So that means their times are a little more consistent and a little closer to that mean value of 16 than what office A's times are. So those are the kinds of things you want to look at when you're actually trying to analyze the numbers that you've gotten from your measurements.